Hello, okay. Welcome to your subject, Bridging Mathematics. Okay, so this is now the start officially of our subject. Okay, we will start discussing your module one. So as I've explained in your introduction, you will be having four subjects in one. Okay, that's why it is called Bridging Math. Again, you will be discussing four subjects. So in here, we will start with the first one, the algebra. Later on, that will be we will be going to trigonometry, and then we will be going to analytic, and then solid. So first, let's discuss the topics of algebra. So let's start with the algebra concepts, or the concepts of algebra. Okay, so that will be our module one, and we have here, of course, the subtopics that will be your units. Okay, so your first unit under module one is to recall, for us to recall first your integers, and then recall your index laws. What are these? And then recall your fractions, because these are the vital, or the very important foundation of your mathematics. Okay, so we will recall with that. By the way, I am your instructor Melchizedek Langluan, and this is the joint presentation we created with Engineer Guzman. Okay, so first is, okay, what are your unit learning outcome? It means that if we will discuss this unit one, what will be your outcomes that will be expected once you will finish this unit one, once you will understand this unit one. Okay, so first is you will be able to recall your concepts of integers, because again we will be needing that one. Recall, of course, the laws of your exponent, and recall the laws of your logarithm. So those are your index laws. And then, of course, we will recall the concept of your fractions. That is very important, because based on my observation on the other mathematics subjects that I am handling, the weakness is in this one: integers, fractions, exponential, and logarithms, the basic of mathematics. Okay, so we will start with your integers. Okay, so this is just a recall. So in addition, okay, let's say positive, we will be adding that one with a positive number or integers. Positive integer plus a positive integer will be, of course, positive answer, or positive integer as the answer. Negative plus a negative will be a negative integer also. But this is where it will be a little bit complicated. Okay, positive plus a negative, it could be a positive answer or a negative answer. That depends. Okay, so what we will be doing here is, it doesn't matter which one goes first, plus or minus. Okay, as long as you are adding a different signs, all you need to do is subtract the digits. Okay, let's say you have a negative 1 and a negative a positive 2. All you need to do is focus on the numbers 1 and 2. Subtract this one, and then the answer follow the sign of the bigger number. Okay, for example, you have a negative 3 plus 2. Okay, you are adding a different signs. So all you need to do is subtract the 2 from 3, so that will be 1, and we will follow the sign of negative, the higher number, which is negative 3. So your answer will be negative 1. Okay, so that is your recall on your addition of integers. How about subtraction? Let's say you are subtracting an integer a and b. Okay, so I did not write it this way, because actually, if you will try to subtract integers, that will just be going back to the laws of your addition. So if you have, let's say, first integer as a, you are subtracting there your b, all you need to do is change the sign of your subtrahend. If you say subtrahend, that is the one that is subtracted from the mean wind. Okay, this is your mean wind, the one we are subtracting from, and your subtrahend is the one that we are subtracting. Okay, so change the sign of the subtrahend. So we will change the sign of whatever that b is. If that is positive, that will become negative. If that is negative, that will become positive. And then proceed to addition. So we will go back to the rules of your addition. Okay, so all you need to do again, if you are subtracting, all you need to do is change the sign of the subtrahend, and then proceed to addition. Okay, so how about multiplication? That is simple. Positive times positive is positive. Negative times negative is also positive. So as simple as the same sign will always be positive if you are multiplying the same signs. And then how about if positive times negative, or negative times positive, or in short, different signs? If you are multiplying different signs, that's the only time that you will be having a negative answer, negative integer answer. Okay. So again, the same signs will be positive, different signs will be negative. That is actually the same as division. Positive divided by positive is positive, negative divided by negative is positive still. So different signs will be negative. So multiplication and division are the same rules for integers. Okay. So let's go to your laws of exponent. So this is very, very important, guys. Okay. So the first rule is that if you are multiplying, okay, if you say exponent, we are dealing here now with exponent or powers. Okay, so you have there a, let's say a, this base are the same. So if you are multiplying the same base, even with different exponent, all you need to do, if you will combine this one, multiply that one, all you need to do is copy this the base, since the base is identical. So just copy a base and then combine the exponent. Just add your exponent since you are multiplying. If you are dividing, okay, the same base of different exponent or the same exponent, it doesn't matter. Okay, as long as the important here is the same base, a and a. So if you are dividing that one, instead of them to add, they will now subtract. Okay, so the upper exponent minus the lower exponent, or the exponent on the numerator minus the exponent on the denominator. So that's it. Copy and then subtract. So if you are trying to get the power of a power, this is a power of a power. If you say power of a power, you have exponent and you are going to raise that one again. So that's it. So what happens with your exponent original and your new exponent? All they need to do is they will multiply. Okay, so the same base, just copy the same base. Okay, a times b. Okay, if you have there two functions, let's say two different functions inside, and you are raising all of them into a single power, actually you can distribute your exponent. Okay, that is the same as this. The same as if you are dividing, if you have a division of different functions and they are all raised to an exponent n, you can distribute also the exponents. Okay, and this is important also in manipulating your equation. You have there a base with exponent, and you want to transfer that one across the bar. Okay, this is your bar, division bar. We call that one the bar. Okay, if you will transfer a term with exponent across the bar, you can do that one actually. Okay, you can do that one, but you should change the sign of your exponent. Okay, so let's say that a raised to n is originally on top. You can put that one below, but that will become a raised to negative n. Okay, but in this case that a raised to n is below, so you will put that one on top as it will become a raised to negative n all over 1, but actually you can take away that one since there is no effect of that. So that is your laws of exponent. These are the important laws. So okay, this is the common mistake of the others. They are trying to simplify, they are trying to make their own laws of exponent, which is wrong. Okay, if you can see that what you're trying to do is not, okay, is not with your laws of exponent, that means that is wrong. That is a wrong mathematical method or wrong procedure. So do not continue. Okay, so that is the common mistake of the others. They are insisting. So it means that they are creating their own rules. Okay, so that is wrong. How about logarithm? Okay, actually these are discussed in your 4 years, the first 4 years of your high school. So you had your basic math, algebra, basic trigo, and then geometry, isn't it? Okay, so these are just recalls. Okay, so laws of logarithm. Okay, if we say log a to the base b, that is how we will read this one. Okay, logarithm of a to the base b, that could be written as log a all over log b. Okay. By the way, what is log? If there is no base, if there is no written base, automatically that is, okay, let's say for example here, log a, automatically that is to the base 10. Okay, that is your base of logarithm. Your logarithm. Okay, your simple logarithm, the base of that is automatically 10. So what does that mean? That could also be written as log a over log 10. However, since again logarithm has a base of 10, Logarithm of 10, if you will try to input that one in your calculator, that is equivalent to 1. That's why we do not need to be writing that log 10 below your log a, or you do not need to be writing that log to the base 10 if you know that your base is 10. Okay, because logarithm of 10 is 1, since 10 is the constant of logarithm. Okay, so we have here your ln. Okay, what is the difference of log and ln? Your ln is what we call as the natural logarithm. In your basic or your ordinary logarithm log, that is to the base 10, but in ln we have here your base e, your number e. Okay, that is our natural base, natural constant base. Base of our natural logarithm. E, constant e, that is 2 point something, isn't it? Okay, so that is your constant e. You can find that one if you are calculating using your calculator. You can see there your e. Okay, so instead of writing there log of a to the base e, if your base is e, automatically you can make use of your ln, which is your natural logarithm. But the meaning of that is as log a to the base e. So if you will rewrite that one, you can write that one as log a all over log e. Okay. So these are the additional laws which are important. Let's say log, if this could be log or ln, it doesn't matter again. The log and ln only differs with their base. Okay, let's say you have their log mn to the base b. M and n are different functions. They are multiplied together, so actually you can rewrite that one into log m to the base b and log plus log n to the base b. If you have functions inside your logarithm which are multiplied, you can actually separate them into individual, which they are all positive. Let's say the other way, instead of product, they have here division. So you can rewrite that also, okay, as log m to the base b minus log n to the base b. Your divisor will always be negative. So let's say there are two products on top and there are two products below. It means that the two products on top, if you will separate them, they are all positive, and the below or the divisor, they are all negative. Okay, so it doesn't matter even if they are more than one or more than two. So that is your product rule of your logarithm and division rule of logarithm. And this is important also, okay? This is commonly used in especially in our calculus. This is the power rule of your logarithm. If you have there, let's say log a and to the base b, but your a there is raised to an exponent, okay? Any exponent, it could be a number, it could be equation. If you are applying their log, then you can actually bring down that exponent before your logarithm. Okay, so you can rewrite this log a raised to n to the base b as, okay, n will go first, and log a to the base b. Okay, that is how exponent and logarithm connects. This rule. Okay, we will be needing this one in your calculus once you will proceed, and so with your calculus too. Okay, so again, that is important. Laws of logarithm, exponential, integers. So let's proceed to your fractions. Okay, addition and subtraction of similar fractions. By the way, if you say similar fractions, these are fractions with the same denominator. Okay, if you are adding and subtracting, it doesn't matter. Fractions with the same denominator, we call that one similar fractions. It is as simple as copying your just copy your common denominator. Okay, you're the same denominator, and all you need to do, if you are adding, then all you need to do is add your numerators. If you are subtracting, then you'll subtract your numerators. Okay, that is adding and subtracting similar fractions. How about if we are adding and subtracting not similar fractions? If we say not similar fractions, they do not have the same base, the same denominator. You cannot just follow this one, okay? That's wrong, because in the first place, you do not know what denominator you are going to use, since they are different. So what we are going to do is make them first similar. If they are not similar, let's make them similar, okay? So how are we going to do that? Let's say consider here a number e. let's say your E is your LCD. That is your LCD, least common denominator. What does that mean? Just think of a number, the smallest number that could be that could be divisible by B and your D. Think of as the smallest number that could be divided by your different denominators. Okay, that number should be divided by all. So that uh, should be divided by all the denominators. Okay, in order for you to say that that is your LCD. So let's say that is your E. Okay, so let's put there E so that they will become now similar fractions. However, there will be a change in your numerator in all of these fractions. Let's say you have 2, 3, 4, 5 fractions. That is what happened. Okay, think of a number that could be divided by all of their numerators. If they are 5 fractions, that should be divided by the 5 denominators. Okay, then you will change the numerator. Of course, how will you do that? Okay, the LCD, divide that one by your existing denominator. Okay, E divided by that existing denominator B, and you will be having here a number. Multiply that one with your original numerator, the same as your other fractions. So here in your second fraction here, E, okay, divide that one by D, multiply that one with your original numerator C. So that, okay, this will just be a number, single number and a single number. So you will now be having similar fractions. Why similar? Because your numerator are now the same. Okay, so all you need to do is go back here, follow. If you are adding, copy the base, then add. If you are subtracting, copy the base, then subtract. Okay, so again, LCD. That is the smallest number that could be divided by all the numerators. Okay, multiplication of fractions. This is simple. Multiplication of fraction as simple as multiplying numerator to numerator, denominator to denominator. Okay, that is simple as multiplication of fractions. How about division? This is almost like your fraction. However, okay, let's say A over B divided by C over D. We will try to get the reciprocal or the reverse of your divisor. Divisor is the one that is dividing. Okay, divisor is the one dividing your dividend. This one, the original is what we call the dividend. The one dividing that one is your divisor. So all you need to do is flip or get the reciprocal of your divisor and proceed to product. Okay, so if that is now a product, go back here, which is the same. Just multiply numerator, multiply denominator. Okay, so again, if that is division, just get the reciprocal of the divisor and proceed to your product or multiplication. So that's it. Let's try now to apply this one in such examples. Okay, so first, okay, x raised to 3 times x raised to 8. Okay, by the way, multiplication could be denoted by x. That is the simple, that is our convention sign for product. But you can actually make use of grouping signs. So if you'll try to look here in number 2, that means they are product. Or you can actually make use here of dot. Okay, dot which is at the middle. That means product. Or also, you can make use asterisk. But that is commonly used on programming. Okay, so that means x raised to 3 times x raised to 8. And actually, that is just following your laws of exponent. They have the same base. So all you need to do is copy the base and then add your exponent. So 8 plus 3 is 11. Number 2, okay, you are multiplying this one. Okay, so how are we going to multiply that one? This is a single or a simple term. That is a simple term. But this is a combination of 2, a combination of 2. So the same. It's just like everything is multiplied. Okay, so what are we going to do? We can only combine there the same base, isn't it? That is the law of your exponent. You can only combine the same base. So x there is combined here with x, which will be x, and that will be adding your exponent, which will be 5. And then y will combine with y. 1 plus 4 will be combined as 5. So this is your answer. You are multiplying these two quantities here. Okay, we are dividing. Dividing, what happens instead of add, they will subtract. So x and x, x and x. So You have exponent below as 1, that exponent on top is 2, so 2 minus 1 will be 1. So your resulting exponent for x is 1. Your y, okay, 5 minus 3 is 2, so that is your number 3. And then number 4, okay, that is a power of a power. So what happens again? They will just combine. So 5 times 2 is 10. Okay. Number 5, the same. Okay, but this time you have here a product of 6 and x raised to 3. So again, if you will try to go back there, that is in this rule or law, you can distribute. So if I will do that, distribute square with your 6 and square with your 3. So 6 is squared, x cubed is squared. So 6 squared, that could be simplified into 36. X cubed, just like the rule here, they will just multiply it with your square. So that will be x raised to 6. So that is your result of this. And then here, that is division, that is the same. Distribute your exponent. So distribute, that will be on top and below. But of course, you will distribute that one, that is product rule. So that will be 2 raised to 3, x raised to 3, and y raised to 3. And then below 3 raised to 3 and y squared raised to 3. So this will become 2 raised to cube. 2 times 2 times 2 is 8. X cube, y cube. And then 3 raised to cube is 3 times 3 times 3 is 27. And then y squared raised to 3 is 6. Y raised to 6. So all in all, actually I can simplify this one, isn't it? Look at this. This is cancellation, isn't it? You have that one in your fractions. Or you can simplify, reduce to the simplest form, but still need that. You can actually, there is a similarity, you can cancel that one. Or you can divide the numerator and denominator by that similarity. Okay, so you have here y3, you have there also y6. So what's the similarity? Both of them have y3, so you can cancel that out. So y3 will be eliminated on top and y3 will be removed below. So what will be left is y3 on here and there is no y already on top. So that is your resulting equation. And then number 7. Okay, so again the same. This is your exponent power of a power. But this time a little bit complicated because you have a negative. But first, actually you can first transpose that one. You can transpose across the bar so that it will become positive. But later on I will be doing that. But first I will first distribute your exponent. Okay, but first look here. You have here y raised to negative 4. So that is my first problem. Simplify first the inside before distributing your outside exponent. So what will happen? Since that is y raised to negative 4, that will go down to be y positive 4. Okay, across the bar it will change sign. By the way, do not say that 2, I need to transfer that to make it positive. No, that is the sign. That is the sign of your integer, not the exponent. We are talking here in your exponent. If you will transfer across the bar, that will change the sign of the exponent, not the sign of the integer. Okay, so you cannot just leave that alone. That will still be on top or as a numerator. So this is our resulting here. Y negative 4 will go y raised to positive 4. Now you can distribute your negative. So that will be this one. However, again, let's make this one positive. The exponent outside, let's make that one positive. So your y raised to 4 raised to negative 2 will go positive on top. So it will become raised to positive 2. And this will go below. It will become also raised to positive 2. Okay. And then of course, if you will try to do that, simplify now. This will multiply. That will be y raised to 8. And this will be, okay, distribute. Okay, distribute. Your negative 2 is inside. Negative, your 2 is together with the negative that is raised to your 2. So if I will square negative 2, that means negative 2 times negative 2. So indeed, that is squared. Twice, you will multiply it twice. So negative 2 times negative 2. What is negative times negative? It is positive. So that is positive 4. And then x squared raised to 2, that will be x raised to 4. Okay? So those are just examples for you to recall your integers and then laws of exponent. Okay, how about your logarithm? Let's try to have these 3 examples. So if you say log xy, that means they are product. You can distribute that one as log x, log y, plus log y. They are all positive since they are all product. Log y squared to the base x. Okay, so this is a combination of your this rule here and this rule here your exponent and your to the base. Okay, so what are we going to do? Okay, again, since the exponent of your function that we are, or your expression that we are getting the logarithm, the exponent of that could go before. Okay, but first, okay, let's try to break this down. Separate your base with your upper. Okay, so log y squared all over or divided by log x. That is the meaning of that, isn't it? If you have there log a to the base b, log a on top and log b below, that is y to the base. Okay, so log y squared on top and log x below. But again, if you try to focus here on your numerator, that follows this law of logarithm, wherein your exponent could go before your logarithm. Ano bang ano to? Langaw. Okay, so 2 will go before your log y. Okay, so that's it. This is the other form of your equation. Okay, number 3. That is the same as your what's that? This one. Division, isn't it? The divisor will always be a negative. Divisor will always be negative. Okay, so you have here here. Okay, so log 5x positive because that is a numerator, and then log base to the denominator, I'm sorry. So that is minus log y squared. So that's it. But look here, there's an exponent of the one we are getting the natural logarithm, ln or log, it doesn't matter. So that will go before your ln. Okay, so that is the equivalent. Okay, so that is just manipulating your logarithm. Actually, in this one, by the way, you will do that if you need this form, because there are some cases in calculus wherein we need that one to be combined, we need that one to be separated. So you can do this one vice versa. From this, you can put it that way, or from this, you can put it that way. So in all of this. Okay. So let's have this 3 more examples that will now be dealing with your fractions. Okay, so let's say you are adding here 1/2 plus 2/3 minus 3/4. So that is just following your addition and summation. But since if you are going to look there, your denominator are different, so that is not similar fractions. Let's make them first similar before apply your addition and subtraction. So again, how are we going to do that? Think of the LCD. Again, 1, 2, 3. 2, 3, and 4. You have 3 denominators and they are 2, 3, and 4. Think of the smallest number that could be divided by 2, 3, and 4. And the smallest that I can think of is 12. Okay? So 12. 12 could be divided by 2. 12 could be divided by 3. 12 could be divided by 4. So let's make that one as the LCD. So I will change all of the denominator by that number 12. But there will be an effect in your numerator. It will change also your numerator, isn't it? So 12 divided by 2, that is the meaning of this. Okay, get the LCD, divide that one by existing, and multiply that one with your numerator. So 12 divided by 2 is 6. Multiply that one with your original numerator 1. In your second fraction, 12 divided by 3 is 4. Multiply that one with your existing 2. And your third is 12 divided by 4 is 3. Multiply that one with the existing 3. So that we will now have your equation as 6 over 12, 8 over 12, 9 over 12. But since they are all now similar fraction, you can now combine this one into a single. So 12, just copy your 12. 6 plus 8 minus 9 will end up 5, isn't it? That will end up 5. So your answer here, if you will combine all of these 3 fractions, is 5 all over 12. Okay, so that is your number 1. Let's have number 2. It is a product. Okay, so again, product is multiply numerator, numerator, denominator, denominator. Simple as that. So you have here x times the, you have here more than one term, isn't it? You have here. Okay, so again, just multiply your numerator, numerator, denominator, denominator. However, if you'll try to look here on your numerator, you have more than one term. Okay, you have more than one term. So do not forget to enclose that one with a grouping sign. Okay, that is a common mistake. If you have more than one term, always, and you are multiplying, always put that one inside a grouping sign. So what will happen? X will be multiplied with the quantity. That is how we will read the grouping sign. The quantity x minus 2. Okay, that is the product of your numerator. And below, I will be multiplying your y with your x times y. So again, what happens? Y and y will combine. So y raised to 1 times y raised to 1 will be y squared. So that is the product here. Actually, you can simplify this one. You can multiply your x inside. So that is your algebra, isn't it? Multiply x, that will be x squared, or that will be minus 2x. However, since x is already there outside, it is already factored outside, and you have that x also below, that's that, isn't it? That could be cancelled. Okay, that is in fraction, simplifying fractions. If you have a similarity on the numerator and denominator, you can actually factor that out and then cancel. Okay, so since that is already outside, do not put that one inside. Since there is a similarity below, you can now cancel that one right away. Therefore, your resulting fraction here, the simplified form here, is x minus 2 all over y squared. Okay, number 3. This fraction we are dividing by that whole number, but actually a whole number could always be transformed into a fraction. All you need to do is put a denominator of 1. That is your whole number, isn't it? So that will be y over, that could be rewrote as y over 1. However, we are dividing, so what are we going to do? Again, dividing, flip or get the reciprocal of that denominator, divisor, and then proceed to multiplication. So that is what happened here. That will be originally y over 1. So I will now flip that one. It will become 1 over y, and then I will proceed to multiplication. So, okay, y, 1 times that, nothing happens. Y times xy, that will be still xy squared. So here, please do not be confused. In here, we cancelled xy. Your x there is outside, separated. That means there is an x here, there is an x here, and I brought that one, that similarity outside. But in here, you have their x, yes, you have their x. But on the next term, there is no x. So I cannot factor out x so that I can cancel. Do not, okay, that is the common mistake. The others just cancel x and x right away, which is very, very wrong. Okay? You will only cancel if they are factored outside. But in this case, you cannot do that because there is no x in your 1. So you cannot bring out x. Okay? So that is examples of your fractions, exponents, logarithm, and of course, at the same time you're playing around with your integers. Okay, so that is our unit number 1. Okay, so I will continue right away with your unit number 2. I will combine this one in your video. So if you have any question, again, just comment that one in your video. Okay, so let's proceed with your unit 2, operations on polynomials. Okay, we will now proceed in your operations. If you say operations, that is addition, subtraction, multiplication, and division of polynomials. If you say polynomials, okay, by the way, this is just a recall also because you already know that one. If in equations, we have what we call as 1 term, 2 term, 3 term, and so on and so forth. Okay, if you say 1 term, that means that is only one term. There is no other like plus something, minus something. That is just as simple as that. Okay, for example, we will go back there. This one is a single term. Okay, that is also a single term. That is a single term. But if you'll try to look here, this is a double term or 2 terms. Why? It is separated by plus. This is also a 2 term because that is separated by minus. Okay, so if you'll try to look here in the numerator here, 6 plus 8 minus 9, that is 3 terms. There are 3 separated by plus and minus. Okay, so that is polynomials. We have what we call as the first one, a single term is, we call that one monomial. A double term or 2 terms is called binomial. A 3 terms is called trinomial, and so on and so forth. Okay, we are just attaching prefixes in your polynomials. Okay, so in this unit, you will be expected to show us these outcomes. Okay, To apply, you should be able to apply operations in your polynomials, and at the same time should be able to simplify algebraic expressions, because once you will be applying addition, subtraction, multiplication, division, there will be such cases that your answer could be brought down into its simplest form. So that is what we call simplification. Okay, so addition and subtraction of polynomials. Okay, first let's try one example, because this is actually simple. We can just recall that one. Addition of polynomials. Okay, so it doesn't matter in addition and subtraction, and the operations actually it doesn't matter if they are the same type of polynomial, if they are monomial, monomial, binomial, binomial, it doesn't matter. Okay, if they are different types of, or yes, types of polynomial. So, but in this case, it so happened that they are all trinomial, so it doesn't matter actually, even if one there is monomial or binomial. Okay, so all you need to do is find the sum of the expressions. So what are we going to do? If we are adding polynomials, all you need to do is combine those terms. If you say terms again, those are separated by plus and minus. Combine all the terms which are similar. Okay, we have the term similar terms. If we say similar terms, those are the terms with the same variables. Okay, the same variables. For example, in here, 3x and negative 5x are similar terms. They are the one with the same variable. If you'll go here, 5ab and negative 5ab are the one with the same variable, so they are similar. But if let's say this is 5a only and that is 5ab, you cannot say they are the same variable. All of the letters or your variables should be the same. If you have 3 letters or 3 variables in this term, that should all be the same to the 3 variables of the other term before you will say that they are similar terms. Okay, and in addition, subtraction, those are the only terms that you can combine. Similar terms, the similar terms, those are the only terms that we can combine. We can add, we can subtract. Okay, so arrange. All you need to do is arrange this one. So I will just arrange this one. X, Y, and constant. Okay, by the way, a term with no variable is constant, isn't it? So x, y, 5. This one is y, x, 5. So y, x constant. So all I need to do is rearrange so that x first, y first, and before y, and then the constant, so that I can combine similar terms. Okay, so 3x minus 2y minus 5, that will be rearranged into negative 5x plus 7y minus 8, that will be arranged into negative 12x, negative 8y, positive 13. I will add all of these. Okay, so combine 3x minus 5x minus 12y. That is now dealing with integers, isn't it? That's why we recall your integers. 3 minus 5. Okay, 3 minus 5 is what? 3 minus 5 is negative 2. Okay, negative 2 minus negative 12, that is negative 14. Okay, by the way, especially those, since again, you do not have mathematics on the previous 2 years of your senior high, maybe you will take time to recall all of this. So if you have a calculator, you can actually make use of that to verify, but do not rely on your calculator. Okay, do not rely on your calculator. Try to exercise also your brain. Okay, so again, 3 minus negative 5 and minus 5 is, or that will become plus negative 5, so that will be negative 2. And then negative 2 plus negative 12 will be negative 14. Okay. How about here? So of course, that's why we need to combine only similar terms, so that the variable, all you need to do with the variable is copy. Okay, so x, that will just become x. Now let's go to your y variables. So negative 2 plus 7, that will be positive 5. Positive 5 plus negative 8 will be negative 3. So bring down y, so that is y. And then with the rest, the constant, okay, negative 5 plus negative 8 is actually negative 13. If I will add that one with positive 13, it will cancel out, it will become 0. So actually there is no resulting constant in our answer. Or you can look at here, look at the similarity, there's a negative negative, you can actually rewrite that one, that is simplification. Okay, there is a similarity here in these two terms. You can bring that one outside, which is actually the similarity is only your negative sign. You can bring that one outside, so that is negative 4 10x plus 3y. If you are not sure of your simplification, you can bring that back. That should be the same. Okay. So that is our answer for your example in your addition. So even if I will give you a lot of examples, that will always be the same process. Again, by the way, to give you an idea, in mathematics, you do not have to be having a lot of examples. Okay, you do not need to be the one teaching you. It doesn't need to be giving you a lot of bombarding you examples, because actually in that case that will actually lead to confusion. Okay, based on my experience. Okay, that is based on my experience, because as they give you a lot of examples, your mind now will be focusing on the example compared to the other examples. So the case there is just like you are now memorizing each type of example, which is wrong. In mathematics, okay, this concept could be applied in different examples. So all you need to do is memorize or know how to apply the total concept. Okay, the total concept. And the concept here is that all you need to do, if you are adding and actually subtracting, that is the same. If you are adding and subtracting, all you need to do is combine those with similar terms. As simple as that. Okay, as simple as that. It doesn't matter if they are different types of polynomials. So if you try to look here, let's say your second polynomial here, there is no constant. It's okay. So what will happen? There will be no negative 8 here. It's okay. Okay, if there is no negative here, negative 8 here, then that will just be the constant that will be added. So it doesn't matter. Okay, you will have a lot of examples as long as you understand the concept. In addition and subtraction, all you need to do is add and subtract those that are similar. Okay, so let's have an example for your subtraction. The same. Okay, but let's consider we are subtracting here integers. So let's consider your law or your rule in your integer. If you are subtracting, all you need to do is change the sign and proceed to addition. Okay, so in here, subtract negative 4y plus 5ab minus 3c from your 3x minus 5ab minus c. So here is my solution. Okay, again, you can only subtract and add similar terms. So how, it's up to you. You can rearrange this one in a manner you want, but for me, okay, let me follow the arrangement of this. X, AB before your constant. By the way, before C. Okay, say C. So, okay, so that's it. But I will be writing below under its similar term, okay? But here that is X, so that is not similar as Y. So there is no alignment with your X, and there's no alignment with your Y. They will be different terms. You cannot combine them since they are different terms. Okay, but if you try to look here, with your negative 5ab and positive 5ab, they are similar, so you can subtract that one. And so with negative c and 3c, negative 3c, that is similar, so you can subtract them. That's why I will be writing on the same column the same terms or similar terms. Okay, but do not forget we are subtracting, so enclose. Do not forget enclose that one. Enclose, so that will be minus. So what does that mean? 3x, we are subtracting nothing from that, so that will just be brought down. And then there is no such term the same as your y, the same as your negative 4y, so that will be blank. So just like 0 minus negative 4. So what will happen, isn't it? Change sign of the subtrahend. So your subtrahend is negative 4y, it will become positive 4 and proceed to addition. Or just like multiply negative, it will become positive 4y. So 0 plus 4y will be 4y. Okay, that is how we ended up here with 4y. In here, negative 5ab minus positive 5ab. So change again that one into negative, this will become plus. So negative 5a plus negative 5a will be negative 10ab. I mean ab. Okay. So that will lead us to negative 10ab. And so it is. Okay, change your negative 3c into plus. That will become summation or add. So negative c plus negative positive, this will become positive again, guys. So negative c plus positive 3c will be ending up with positive 2c. So that is your answer here. That is addition and subtraction. Okay. Multiplication. Okay, let's have three examples with your multiplication. So here is your multiplication of polynomials. Okay, this is a single term, so that is monomial, and multiply with two terms, that is binomial. So it doesn't matter again. All you need to do, since that is a simple term or a single or a monomial, all you need to do is distribute. Okay, multiply in all of the terms inside your grouping sign. So that will be 2x times negative 3x. So positive negative will end up negative. Okay, so negative 6. 2 times 3 is 6. X and x will be x squared. 2x minus 5x squared. Okay, that will be still negative since we are multiplying different signs. 2 times 5 is 10. X and x squared will be x cubed. Okay. Number 2. Binomial with binomial. Binomial with binomial. So here is the point here in multiplication. If you are multiplying, you should be multiplying all of the terms in each of the terms on the other side or on the multiplier. So you have here two terms in your the one we are multiplying, and you have here two terms. So all you need to do is multiply. Okay, focus on the other one. I will be multiplying x in all of that. So I will be multiplying x in all of that, 2x plus 7. And I will be multiplying that negative carry the sign. Okay, carry the sign. I will be multiplying that negative 5 with all of that. So x times all of this plus negative 5 times all of that. Okay, it's up to you. You can take the sign or you can leave the sign. Okay, if you will take the sign, that will be added. If you will leave the sign negative, that will be negative outside. So minus 5, you will only take 5, but it doesn't matter. It's up to you. Play with that, but do not be confused. Okay, because that is the common confusions. For me, I will consider the negative. So I will take with me your negative, so that will be multiplied negative 5. So I will add all of that. So negative 5 multiply with all of these, so that's it. Then we will go back here just like on top, distribute. So 2x squared, 7x. In here negative 10x, negative 35. Okay. So all we need to do now, okay, you can say this is your answer, but actually simplify, collect similar terms. If you say collect similar terms, combine all these similar terms. So 2x squared, that's it. No other terms like that, so remain. In here 7x, and that is negative 10x, so they can combine, isn't it? So 7x plus negative 10x, this will combine as negative 3x, and then of course your constant positive, this will be still negative 35. Nothing combines with that, so it will still be negative 35. Okay, so that's it. Now with your example number 3, the same actually, but this time you are multiplying binomial with trinomial. So it doesn't matter again, as long as, but of course, the more the terms, of course, the longer your solution. Okay, but the process will always be the same. Multiply all the terms on the other side. Okay, so I will, let's say, multiply x in all of that, and then multiply negative 2y in all of that. So that is what happened here. Okay, x multiplied to all of this, and then negative 2y, I will carry negative with me, multiply in all of that. Okay, so what will happen, this will be x squared x will be x cubed, x 2xy, that will be 2x squared y, x with your 4y squared will be 4xy. Okay, they will not combine since they are different variables. Multiply your negative 2y inside, that will be negative 2x squared y. Okay, by the way, if you are doing a multi-variable in a single term, always arrange that one alphabetical. It is better for you to arrange that one alphabetical so that you can see right away. Okay, just like here, isn't it? You can write actually that one as 2yx squared, negative 2yx squared, but better write it alphabetical. Since if we will do that one, you can see right away. If you will try to look here, is there the same quantity with that? Actually here, by merely looking at that, x squared y, they are similar, so you can combine later on. But first, let's distribute. So negative 2x squared y. Okay, negative 2 and 2 will become negative 4x, and then y and y combines as y squared. Okay, Negative 2 and 4 will become negative 8. Y and y squared will be y cubed. So we are done multiplying. All you need to do is simplify, combine similar terms. X cubed, okay, nothing the same as that. So remain 2x squared y. That is the same as this, but that is negative. We are adding that with a negative, exactly the same as that. So they will cancel. 4xy squared. We are adding exactly the same but negative. So that will cancel. Now this will be, we have one left. Positive plus negative. So that will be still negative 8y cubed. So your resulting here is x cubed minus 8y cubed. Okay. So that is our answer for multiplication of polynomials. Let's have division. Okay, this will be our final for this video. This is the final discussion for this video. Okay, if you are dividing, it matters. It matters here. You should know if that is monomial, polynomial, binomial, or other higher. Let's say you are going to divide this equation or expression by this one. This is a single term. Because if that is just a single term, it is simple because all you need to do is divide all the terms by that single term or your monomial. So since we are dividing all of these, all you need to do is divide all of these terms by our divisor since that is monomial or single term. So what will I do? You can distribute that one again. You can distribute since that is a simple term, single term. So if I will distribute that one, of course, follow your signs. That is minus, so that will be minus. So now simplify this one. This is just a fraction. Look at the similarity. Cancel that one. So 4 divided by negative 2, that will be negative 2. Isn't it? A squared divided by A. So A and A cancels. What will be left will be A on top. B4 and you have here B3. You have 3. Cancel B3. You have left B on top. So that is your result in your first term. Here, in your second term, minus. So, 8 divided by negative 2 is actually negative 4, but that will be multiplied with your negative, so it will be positive. Okay. So again, 8 divided by negative 2 is positive, negative 4, but that will make it positive because of that minus. So you have here 4 on top. And then A squared and A below, so cancel AA, you will be left with 1A on top. B, and then you have here B3, so your value of B below is higher than on top. So if I will cancel the similarity, which is B and B, I will take away B on top, take away B below. So there is no B on top, but there will be left B squared below. Okay, that is cancellation. Here, okay, the negative and negative will make it positive again. 2 divided by 2 is 1. B, is there a B below? Yes, B squared, and that is B3. So this is bigger below, so what will be left is below, which is 1B. And in A, there is nothing that will cancel with that, so your result here in your third term is 1 over AB. So that is your result. Can you simplify this further? No. So that is our result for this example 1. Okay. Example number 2. Example number 2. Okay. So this is your example number 2. We are now dividing. Okay, we are now dividing using a divisor which is not a single term, which is not a monomial. So we cannot do just like the process of dividing using a monomial. Okay, you cannot just distribute. You cannot do that. Okay. So what we are going to do is follow just like your long division before in your integers. If you are dividing numbers only, isn't it? You are doing long division, this sign. So that is the one here that we'll be using. So the same. The dividend, that is the one being divided, should be inside, and the divisor, the one dividing, should be outside. See? So this you should know this one, okay? If you are dividing using a long division in a polynomial, you should arrange that one, okay? Arrange your polynomial into a decreasing manner, okay? Into a decreasing manner with respect to exponent. Let's say you have their x, so arrange the exponent of x decreasing. So it so happened that that is already arranged, so no problem. Of course, the same with your divisor, you need to arrange that one, but that is already arranged, so no problem. But in this case, for example, in this case, okay, they are not arranged, isn't it? So what will I do? I will arrange that one. X cubed before x squared, before x, and then before constant. If something is missing, don't worry. All you need to do is arrange. Okay, even if there is no x there, then no problem. There is no x, as long as that is arranged. In this, that is already arranged. Okay, by the way, what if there are two variables, let's say x and y, which are mixed in terms? All you need to do is focus. If you are arranging, focus on one term. Okay, if you arrange the terms with respect to x and decreasing, that should be also be done in your divisor. Okay, arranged with respect to x. If you arrange with respect to y, you should arrange also with respect to y. Okay, ano yan lang. Okay, so that is what we will be doing. Okay, so arrange, that is already arranged, that is already arranged. So all we need to do is proceed. So this is now the difference of a dividing polynomial using long division in dividing a number using long division. Okay, in number, just proceed with your number by number. You are dividing number by number, isn't it? But in here, we are dividing term by term. And, okay, focus on the first term, divide that one by the first term. As simple as that. First term divided by the first term. So x squared divided by x, that will give us the answer x. Don't worry, if you are dividing, don't worry on the pair of your divisor. Just focus on the first of your divisor and the first of your dividend. So x squared divided by x is x. We are done. All you need to do is bring back, isn't it? That is your long division. Multiply x again back. Subtract that one later. So x times x will be x squared. And of course, this time, even if you did not use that negative 5, if you are now bringing back, you need to multiply. Okay, so x times negative 5 will now be negative 5x. Don't forget that those are all subtracted. Isn't it? That is our role of long division. Okay, so that's it. If I will now subtract, okay, x squared minus x squared cancels, of course, they are identical. 3x minus, okay, we just like subtracting, isn't it? We will only subtract similar terms and add similar terms. Okay, so 3x minus negative 5, so this will become positive, that will become plus. So 3x plus 5x will be 8x, positive 8x. What did we not yet use? We did not yet use that negative 40. So bring that one below. So this is the resulting. Okay. Can we divide that one further? Yes, we can still divide 8x by x, isn't it? 8x divided by x is 8. Do not again worry about your negative 5 if you are dividing. Now, bring back 8 times x will be 8x, but later on we will subtract that one. And then, of course, now make use of the pair. 8 times negative 5 will be negative 40. Okay, we will now subtract. Actually, they are all identical, so all of them will cancel. That will be 0. There is no remainder, so your answer is as your x plus 8. Okay, if you are not sure of that, you can check that one by multiplying, isn't it? This is your divisor. This is your answer. If you will multiply that one, that should go back to the answer. You can do that one. You can try. Okay, let's try. Let's try. Okay, since I have here my blackboard. So x minus 5, your divisor, multiply that one with your answer, x plus 8. Okay, multiply. Binomial. This and that will be x squared. This and this will be 8x. This and that will be, consider negative 5x. This and that will be negative 40. Simplify, combine terms. X squared, this will become positive 3x. This will become, that will leave us 40. So is that our divisor? We'll try to go back on our divisor. X squared plus 3x minus 40. Yes. Okay. So let's proceed with the second example. Okay. Let's proceed with the second example. So you are dividing this again, so we will arrange this. This is our dividend. Arrange that one into a decreasing manner with respect to x, since that x is our variable. Okay. So x cubed before x squared before x before the constant. So that's arranged this way. That is already arranged. Okay, so now let's just divide. First term divided by the first term. 4x cubed divided by 2x. 4 divided by 2 is 2. So isn't it that is 2? X and x will cancel, so you are left with x squared. Okay, so the answer is 2x squared. Multiply back. That should be the same. So yes, 4x cubed. But that later we will subtract 1. Make use of your partner. 2 times negative 3 will be negative 6x squared. So you can combine that one here. That is the reason why we are arranging, isn't it? That's the reason why we are arranging. So now that's it. You will subtract. That will cancel, of course. But this negative 8, this will become plus 6. So it will end up with negative 2x squared. We did not yet use your 9x and then 7. So bring that below. Divide further, continue. So negative 2x squared divided by 2x will be negative x, isn't it? Bring that back. Negative x with your 2x will be negative 2x squared. Negative x with your 3, negative 3 will be positive 3x. Subtract that one. This will cancel. This will 9x minus 3 is negative 12, isn't it? This will become plus, that will become negative. So negative 12x. Bring down. We did not yet use 7. Bring down 7. Okay, divide. Can we divide further? Yes. So negative 12x divided by 2x is negative 6. Bring that back. Negative 12x. Bring that back will be positive 18. Subtract. It so happened that they are not identical, but let's see what will happen. Okay. 12x cancels. Negative 12x and negative 12x cancels. 7 minus 18. Okay, that is negative 11. There is a resulting answer, not 0. So can we divide that further? No more. You cannot divide that one because this is a constant and that is a variable. So your expected answer there is a fraction. So all you need to do is get your remainder. If that is plus, then we will add. If that is negative, then we will minus. Okay. Since that is negative, that will be minus. Okay, your remainder, isn't it? Remainder, we call that one remainder. That there is a value instead of 0. Remainder divided by divisor. That is how we will write that one here. So this is your answer. 2x squared minus x minus 6 minus the fraction 11 over 2x minus 3. Okay, let's check that one. If you will multiply again the answer by the divisor, that should go back to your dividend. Okay, that will go back to your dividend. Okay, so this will be a little bit bloody, but we can do that. Okay, let me just check. Okay, so how many minutes already? 1 hour. Okay, good. So we will multiply 2x minus 3 with your 2x squared minus x minus 6 minus 11 over 2x minus 3. Okay, so all I need to do is multiply first this one. So 2x will be 2x squared. 4x cubed. I'm sorry. 2x squared will be 4x cubed. 2x and x will be negative 2x squared. 2x and that will be negative 12x. Multiply that here will be negative. Okay, numerator 22x all over 2x minus 3. Now, multiply your negative 3. Negative 3 and then 2x squared will be negative, but x squared. So I can write that down right away here below so that I can combine that one later on. Negative 6x squared. This and that will be positive 3x. This and that will be positive 18. So let me first indent this one. Let me just indent that one so that they will not be aligned since they are different. So that is again 22x all over 2x minus 3. So you have here negative and negative, it will become positive 18. Before negative and that will become positive 3. 3 times 11 is positive 33 all over your divisor 2x minus 3. Okay, maybe you will worry about that, but that is this fraction later on. So we will add, of course, combine 4x cubed, bring down. This will be, okay, negative 8x squared. Okay, negative 8x squared. This will be negative 9x plus 18. Okay, plus 18. If I will now try to add this one, look at this. If I will now try to add this one, I will now try to add that one. Okay. Where are we going to use? Let's here. So let's say here. Isn't it? They are fractions, but they are similar. Isn't it? Okay, here na lang. They are fractions, but they are similar. So just get the LCD. Okay, that will be 2x minus 3. I mean, they are the same, so just copy the denominator. So all we need to do is add, isn't it? Add. Negative 2x, they cannot combine. So negative 22x, and that is positive 33. But if you try to look here, you can rewrite this one, isn't it? Look at that. You look at this one, there is similarity. They can be divided by 11. So actually, if I will do that, you can actually take away negative 11 so that that will become positive 2x. So if I will do that, this will be ending up with, bring out your negative 11. What will be left inside is positive 2x. Isn't it? Bring that back, still negative 22. Bring out negative 11 from that, what will be left is negative 3. If you are not sure, bring back that one, negative times negative will be positive 33. All over 2x minus 3. So that's it. This will cancel since that is the same. So you are just left with 11. You are just left with your 11. So if I will add that one, negative 11, that is the answer to this. You will end up with 4x cubed minus 8x squared minus 9x. 18 minus 11, that will give us plus 18 minus 11 again? 7, isn't it? Plus 7. Is that our dividend? Is that our dividend there? You'll try to look here. Yes. 4x cubed, 8x squared, negative 8x squared minus 9x plus 7. So we are correct. Okay? That is division of polynomials. Please do this one. This is to be submitted. Okay? This will reflect in your canvas so you can see the due date. You can see the due date. Okay, please answer that one. Try this one in your own. Okay, please try this one in your own so that you can see if you really understand or not before you will ask the others. Okay, so if you have any question, this one, we will be discussing that one on the next live, or you will be commenting that one below the video. If you can answer that one by just comments, then that's good. But if not, then we will be answering that one in live. Okay. This is credits for the slides. Okay, this is a free template slides by Slides Carnival. So that's it. Thank you very much for watching.